All right. So again, we've been doing the factoring thing. We start off using the diamond method to figure out what numbers we need here. And then we started doing some actual factoring. We got a couple more of those. And like I said, then we're going to look at something a little more complex, but not too bad. So we'll get to that here in a second. So things have been kind of acting weird today. Let's get rid of this stuff over here. I don't think we need that. There we go. It's better. All right. So we've done most of these. Let's try a couple more here. Okay. So again, the idea is we want to take these guys and factor them into two what they call binomials, and more importantly about the binomials is we want them to be x's, because it's a lot easier to deal with x than it is to deal with x squared. And the reason for that is it's just a lot easier to tell what numbers can you plug in for x that make this thing 0. So kind of a big deal. All right. This comes up in a lot of stuff in actual, physics and business and sports and all kinds of places, to be honest, that they do this kind of stuff in the background that you just don't know about. Okay, so again, first thing we can look at is you say, okay, this guy's negative. When your last guy's negative, that takes the guesswork out, because what you need is you have to multiply two things together and get a negative number. The only way that happens is you have to have one of your terms be plus and one of them to be minus. Now, we've got this extra y thing going on. Now, we know how to handle that. We did that last time. All that requires is instead of this just being a number, it's going to be some number times y. So we're pretty well set up. So the last thing we need to do is we need to come up with the actual numbers. Okay. So again, we can do our diamond thing here. So I need two numbers that multiply together and give me minus 11. We've already established that one of them is going to be negative, right? And add together to give us minus 10. So again, we said when the number in the middle is kind of big, that means your factors are probably going to be spread out. And here's the thing about 11. There's really only one factor that works, right? It's just 1 times 11. So which one's going to be negative and which one's going to be positive? Well, 11 is going to be the negative. Right, good. So if he's 11 and he's 1, he'll be positive 1. So again, this would be positive 1, and they probably wouldn't write the 1 in there, but we'll do it for now. And then minus 11. And like I said, the lazy math guys would be like, well, everybody knows 1x is just x. So we'd probably just go like that. So there's your answer. Okay. And like I said, that's about as fancy as these get because, they stuck that extra y in there. But it's really not a big deal. Okay, so let's take a look at the next one here. So again, we set up shop. Right? X times x is x squared, so we get a couple x's there, right? So plus and plus here, what's that mean down below? We got a plus and another plus. How about our guys that were factored? What are we going to have? Yeah, plus and plus there means plus and plus here. Beautiful. Okay, so then we do our regular thing. We say we got 48. A lot of factors to 48. This might take a minute. And has to add together to give us 16. Okay, so the factors are, they could be kind of far apart, right? So 1 and 48 is probably not our guy because that adds up to 49. 2 and 24, nah, right? That's not going to work either, right? 3 and 16 is another one, but that adds up. So 3 and 16 adds up to 19. We need 16. So what do you think our factors are for this one? And as I said, 48 does have a lot of factors. When you got a lot of factors, a good thing to do is just, figure out the factors on your calculator. So obviously we can divide by 48. And it's an even number, we can divide by 2. And here's an interesting way to know if you can, excuse me, divide by 3. We've got 48 here, right? So the way you can figure out any number if it divides by 3 is you say, I take the individual terms and I add them together. So 48, I'd add 4 plus 8, and I get 12. Can I divide 12 by 3? Yeah. So here's the thing. If you add the individual digits together and the number you get can be divided by 3, that means the original number can be divided by 3. Sneaky, huh? So that's the one where I said 3 times 16, right? Okay. So then a lot of times if you have an even number, it can be divided by 2. The question is, can we divide it by 4? So what do you think? 48, can we divide that by 4? Yeah. So 4 times what is 48? Yeah, if you're not sure, you can grab your calculator, do 48 divided by 4, and that'll give you your answer. Yeah, 4 times 12. 4 times 12. What does 12 and 4 add up to? Ding! That's our guy, right? So we go 12 times 4 is 48. 12 plus 4 is 16. So 12 and 4 is your guy. And again, with these guys here, it doesn't matter. You could write x plus 4, x plus 12. That's exactly the same thing. So the order of these guys doesn't really matter since there's no negative signs or positive signs, negative and positive, like we had over here. This guy definitely had to go with the plus, and this guy definitely had to go with the minus. Okay. All right. Let's go ahead and check out a couple more. Okay. You good, Chloe? Don't need to write anything down? Okay. Yeah, so make sure I wasn't going too fast, all right? Cool. All right, let's check out another one. All right, so this guy. So again, pretty much you can just do this automatically. Go ahead and set up. And then we go x here and x here, right? What's the minus sign mean? Yeah, plus and a minus, right? Or minus is a plus, minus and a plus, as Chloe said. Either one's fine. All right. So this looks an awful lot like the last problem because here's 48 again, right? So we just kind of did a bunch of those guys. But now this guy has to be negative 13. And we've already established that one of the guys has to be negative, right? Okay. So what's our factors this time? I also think of this as when you have a positive and negatives, your factors have to be 13 units apart. So they're pretty spread out, right? So what's our factors in this one? Well, 8 times 5 is 40. So it's not going to get us there, is it? Even though those do add to 13, you're right. But again, remember, this time it's not that we needed to add it to 13. We just kind of need them 13 apart. All right, so let's talk about what we had before, right? So we know 1 and 48 are too far apart, right? Because they're 47 apart from each other. Not good. 2 and 24, they're 22 apart. Yeah. How about 3 and 16? And you're right, 6 times 8 does give us 48, but it's 14, not 13. Right? And again, they need to be farther apart. See, 8 and 6 are close together. They're only 2 apart. So remember, when you have a negative, it's really how far apart they are from each other. Okay, so 3 and 16. Now, which one's going to be the negative? Yeah. So remember, when the overall thing is negative, like it is here, that means the bigger of our two numbers, in this case, the 16 is going to go here. 3 is going to go here. Beautiful. All right, let's try another one. All right, so we'll go ahead and set up shop. Now for this guy, we've got that y squared thing going on, right? So this will be an x and an x. And over here, we're going to need a y and a y to take care of this y squared, right? And then when we do the middle terms, you're going to get x times y. So that's fine. We're good. Okay, plus and plus, what's that tell us? So what's that tell us about our answer if we got plus and plus in the original? Yeah, that's always a good thing. Plus and plus there means plus and plus here. That makes it easy. Right? Okay, so we're all set up. The only thing we have to do now is figure out factors that multiply together and give you 54 and add together and give you 15. And they're both plus this time. So this is a little more like what you were thinking about last time, Chloe. We need to find some factors that add together and give me 15. So what might those be? You know, Gabe and Eli, you feel free to hop in here anytime, guys. Always making Chloe do all the heavy lifting here. So we need some factors of 54. 54 is kind of a funky number, huh? So again, the bigger numbers probably aren't going to work. So 1 times 54, nah. 2 times 27, nah. 3 times 18, yeah. Won't divide by 4, will it? Nah. 5, no good. 6, can we take 54 and divide it by 6? Check that one out. So can you divide 54 by 6? And if so, what's that give us? But you guys don't have calculators either? Okay, that's cool. 9 and 6, yeah, good, Chloe. So again, if you take your calculator, you do 54 and you divide it by 6, you get 9. So wait a minute. 6 and 9, so I know that multiplies together and gives me 54. Okay. And 6 plus 9 is 15. There's our guys. Nice. Okay. And again, like I said, don't let the extra y throw you off. You just throw that extra y in there and we're done. And again, remember, the whole idea of doing this is if you FOIL it back together, you should get this guy back, right? We haven't done that for a while. Let's go ahead and do one of those real quick. So we do the x times x, that's x squared, right? We do x times 9y, that's going to be plus 9xy. They usually write them in alphabetical order. That way they always look the same. Okay. Then we go to the bottom here, and we say I've got 6y times x, that's going to be plus 6, again, xy, write them alphabetically. Then I've got 6 times 9, that's 54. Y times y is y squared, right? So it's looking pretty good. I've got my x squared, I've got my 54 y squared. So I got those two terms. So I just look at these guys. So I've got 9xy and 6xy. That adds up to 15xy. There's our guy, right? So as you see, we get our original guy back. Cool. So that, of course, means you've done it right. Nice. Okay, so let's check out an ACT, SAT type of problem, and then we will throw a little monkey wrench to this thing. See how it differs a little bit. All right, so let's go ahead and check this guy out. Ooh, this must be an ACT problem because there's 5 possible answers. Okay. So in this one, it looks like they start off, remember we started this a while back, we start off by factoring out a common factor for the whole thing before we start doing our trinomial business, right? All right, so notice here that we've got x to the third, x squared, and x. So that means we can bring out an x, right? So we can factor out an x. There's no x factored out here, is there? So he's out. Now, notice some of these have a 4 and some of them don't have a 4. So ask yourself this, can I factor out a 4 here? Does 4 divide into all 3 of these? Will it divide into 4? Will it divide into 24? Will it divide into 28? What do you think? I'm sorry, Chloe, is that a recent yes? Yeah, so that means I can factor out a 4x. So right away, look at this. Just by doing that, we're down to 2 possible answers. Okay. So now if we factored that out, you think it's A? Okay, well, let's see. I think you might be right, but let's check it out. So if we factor that stuff out, if you take 4x to the third and divide it by 4x, you get x squared, right? Then minus 24 divided by 4 is minus 6, right? And then x squared divided by x is just x, right? And then minus 28x divided by 4x is going to be minus 7. The x's cancel out. All right, so it's going to be 1 plus 1 minus. That doesn't help us. But since this is a negative 6, the bigger number is going to be negative. So congratulations, Chloe. You are correct. Cool. And the thing about it is you've done enough of these now where you can kind of get the vibe where it's like, okay, this is kind of a big number. So probably the bigger of my 2 numbers is going to be the negative, right? And once we figured out what we could factor out, we got rid of these 3 answers here. We're down to this, and it's like, well, here's the bigger number with the negative, so that's probably my guy. You're absolutely right. Nice work. Okay, so we got this part down pretty good. So this is a course where they're going to throw a monkey wrench to it. Don't they always? It's kind of like a video game. We've cleared this level, and now when we go to the next level gets a little harder, right? That's pretty standard stuff. So let's take a look at these guys and see what's different about them. What do we need to do here? So what's the first thing you notice that's different? Other than they use different variables for some reason. Yeah, the variable is one thing, but what else? What else is kind of weird about these? What's the strange thing about the first one? So how does this look different than what we've been doing? Not so much the 2. Let's peek back here for a second. So here we've got a squared term, right? And then we go to this guy and we've got a squared term. What's different? What's different with this one as opposed to this one? So that's x squared. What do we got here? It's squared, right? But what else is going on? They stuck a number in front of this thing. Those dirty... Oh, never mind. Those dirty sons of... I won't say what, right? Now there's a number in front of our square term. Really? What's up with that? So here's what's up with that. Now, fortunately for most of these, there's only one way. So what we got to do, remember, we're always talking about the factors over here, right? So our only factors for this guy is 1 and 5, right? So we got 1 times 5. So that's the only factors we can have here, right? But now we got to deal with factors in the front. Fortunately for us, 1 and 3, the only thing that does it is 1 and 3. So what is this telling us? So if we set up shop here, like we were doing before, it's got to be kind of the same, except instead of being a p here and a p here, one of them's going to be p, but the other one's got to be 3p. What's wrong with these guys, right? Okay, so then the next thing we got to look at is we say, okay, this guy's negative, right? So we know what that means. That means one's going to be negative and one's going to be positive, and usually we would just throw them in there, right? But I can't do that this time. And here's why. I've got a 3 in front of these guys. So what's going to happen is when we multiply this back out, whatever number goes right here, when we multiply it back out, is going to get multiplied by 3 in addition to the variable. All right, so what that's telling us is whatever number goes there is going to get tripled, right? And since this is kind of a small number, we're probably going to go with our smaller number over here. And I'll show you why here in a second. Like I said, this is kind of a new idea. And then this one takes a minute, so it's all right. All right, so let's try putting the 1 here and the 5 here. Now here's what's going to happen. We're all about the middle term. This is where things are going to get weird, right? Everything else is fine because 3p times p is going to give 3p squared, check. 5 and 1 will give you 5, check. Got to deal with the sign yet. We're going to get there, right? So now we kind of look at it like this. So let's look at the inside and the outside guys. So the inside guys are the two in the middle. So 5 times p is 5p, right? And then we've got our outside guys. We've got 3p times 1. That's 3p. And we need these guys to equal negative 2p. So which one should be negative then, the 3p or the 5p? Okay, so let's try that. So if we make him negative, that means this guy would be negative, right? And make this guy positive. okay? So now we've got 5p minus 3p, that's positive 2p. We need negative 2p. So what do I need to do? We're almost there. We just got to do one quick thing here. What do I need to do? My signs are off, so what should I do with my signs? Yeah, we just switch them, right? So if we switch our signs, then we'll make this guy minus and this guy plus. So now when we multiply them out, I've got minus 5 times p, so that's going to be minus 5p. One moment, please. So this will be a minus 5p. If I can get this thing to erase, that would be awesome. So that becomes minus, and then the other guy becomes plus. Now I have 5, or excuse me, I have 3 minus 5 gives me minus 2p. That's what we're going for. So this is our answer. So you see the difference is now we have to deal with numbers out in front of our first term. Okay, so it's a little more work, and like I said, it's a little more of a trial and error kind of thing. You saw we tried out the one being positive, and we ended up getting, or the one being negative, excuse me, and we ended up getting positive 2p. So it was like, okay, that's not quite what we wanted, but it was an easy fix, right? All we had to do was, okay, we just switch our signs and we're good to go. Okay, so that's the kind of things you have to be looking for here. All right, so let's look at the next guy. All right, so again, we've got 2n squared. Now, fortunately, like I said, the only way you get two numbers multiplied together and give you 2n squared, or just give you 2, is going to be 2n times 1n, okay? All right, so now we know one's going to be plus, one's going to be minus, but we're not sure how that's going to go just yet. Now, the factors of 9, we've got 1 and 9, right? And then we've got 3 and 3. Now, when this guy's kind of small, smaller than this guy anyway, chances are pretty good that we're going to use the less extreme values for the factors. Less extreme means they're closer together. So 3 and 3 is about as close together as you can get, right? So let's pop some 3s in there. Let's see how that's going to work. So 3, 3. Okay, so the overall thing is positive. So do we need to multiply by the 2 and make that positive, or do we need to multiply by the n and make it positive? Which one should be positive here, the first one or the second one? Okay, so let's try the first. So we do positive here, right, and negative here. So again, the thing you want to check is you want to look at your inside-outside terms. So here, this is going to give me plus 3n, right? So 3 times n is plus 3n. And here I've got 2 times negative 3 is negative 6, and then n. So that gives me minus 3n. So negative for the first, yeah. And that's the thing, like I say, it's easy to check. Because we do a quick check here, it's like, nope, that didn't work, but it's an easy fix. That's the great part. So we say, okay, we got to fix this. So we'll make this guy negative, and we'll make the other guy positive. So that makes this guy negative, and this guy positive, and 6 minus 3 is positive 3, and that's our boy. And there's our answer. Okay? So yeah, it takes a little while. You got to, just like the other ones, you got to practice these guys a little bit till you start getting the vibe of what's happening. You know, we had the vibe down pretty good on this, and then they threw a monkey wrench at us, right? So, but we could get this, okay? So again, just remember, when you have a number here that has an extra number, whatever number I put here is going to get doubled because of this guy, right? So since this is positive, we probably want the positive guy over here. We double up the positive number. There he is. And we got the negative number over here, but he's just times n. And then that gave us what we needed. So the middle term is always the key to these things. Okay, I mean, that was the case in the last one. You know, getting the middle term to match up was the problem, because you could do x times x and get x squared. And whatever the numbers say it was 24, you could do 4 times 6 and get 24. But then again, you could do 3 times 8 and get 24. So it always depends on the middle guy. He's always the problem child. You know, they always say like if there's like 3 kids, the middle kid's always the problem kid, quote unquote. Used to be a really funny show back probably before you were born called Malcolm in the Middle. I don't know if they showed it anymore. It was on Fox. And you're the middle kid. No offense, kid. But Malcolm in the Middle is a funny show if you can find that maybe on Netflix or YouTube or something. But the interesting thing about it is the guy that was like the star of Breaking Bad, Bryan Cranston, he's the dad on there, and he's just like this bumbling idiot, like a Homer Simpson kind of guy. And it's interesting to see him doing that as opposed to doing Breaking Bad, which was really intense. So, but like I say, if you're looking for something that's just kind of silly and fun, it's a good show. All right, let's check out maybe 1 or 2 more of these, and we'll call it. All right. So yeah, just to give you an idea, I remember one that was pretty funny, where the 3 boys all stayed in the same room, okay, in the house, and you hear like all this screaming and yelling and stuff crashing and stuff like that, and the mom comes back and she swings the door open, okay, and the oldest brother, he's sitting over in the corner, he's like holding his face and there's like blood on his hand. The little brother is like duct taped from head to toe like a mummy, and they've got him hanging off of like the ceiling fan. And then you see Malcolm, and Malcolm's got a big flashlight like duct taped to the top of his head. And he looks at mom and he looks at the camera. He says, "I swear on paper, this was a great idea." You can't even imagine what these guys were doing, but yeah, it's funny stuff. All right, so let's go ahead and check out maybe 1 or 2 more of these. Yeah, it's pretty cute. Like I said, it's just silly fun. All right, so same deal. Fortunately, again, like I said, 3 times 1 is the only thing that's going to work here. So we're going to have a 3n and an n. All right, so we got a little bit of a break here because this is a plus, right? So that means 2 pluses or 2 minuses. And we determine that by this guy. So if he's minuses, what do we have here? Yeah, they're both going to be minuses. So we can actually go ahead and fill those in now, since they're both the same. That's kind of nice, right? So now we only have 2 possibilities here for our numbers. We either need 1 and 4 or 2 and 2, because 1 times 4 is 4, 2 times 2 is 4. Okay. So which ones do you think we ought to use? Should we try 1 and 4, or should we try 2 and 2? 2 and 2. And that's a good bet, because here's the thing. Normally with these, the less extreme values, usually try those first. It doesn't always work, but usually try those first, particularly since this number, it's big, but it's not huge, right? So let's do the 2's. We got 2 and 2. So now, like I said, you do a quick check of your inside-outsides. So inside, I've got Okay, so inside, I've got minus 2 times n, so that's minus 2n. And my outside, guys, I've got 3 times 2, that's negative 6 times n. And then we have minus 2, and minus 6 more is minus 8n. Check. That's your answer. Cool? And like I said, we'll be doing this stuff tomorrow as well. So we're just kind of warming up to it at this point. All right, guys, well, that's probably a pretty good stopping point right there. I've already got your attendance, so we're good to go there. I'm going to shut down the recording. Like I said, we'll continue on with this stuff tomorrow. All right, so again, thanks for stopping by, and we'll see you next time.